Have you ever played Minecraft before?
Oh yeah, we play it all the time. I play actually. I play with the whole family, like my kids, my wife, everybody will play.
Oh, nice. Me
So
and my
yeah,
daughter were just playing yesterday, and we found I don't know very much about it, but we created a world, and it had a big river in it, and we found an exotl egg.
yeah,
So
yeah,
like we're just spotting a bunch of these guys in, and that was awesome. That I just had this world. It was like
yeah,
paradise for exotls, and I would try to feed them fishes. My daughter did not like that,
yeah.
but
They like those fish. Like so, we um we do like survival, right? And so our survival bit, because there's like five of us working together. And the youngest one,
oh, that's
the
awesome.
younger two, kind of babysit a little bit, but
Yeah.
um like our base, it has like we made this big like a giant aquarium. And
Okay.
then I explored until I found a coral reef so I could dive, and like you can catch all the different types of, there's like 6,000 different types of fish or something. So I caught a bunch of like interesting ones in buckets and brought them back and then put them in the aquarium. And then we divided the aquarium and made like an axolotl side. And
Mm.
at one point, an axolotl escaped from one side of the aquarium into the other side and just started eating all of our exotic fish because that's what they eat.
Yeah.
Um, and it was horrifying.
Yeah.
So
At first it was like, oh, look at all the cool exoticals just like swimming around, and then we noticed like on top of the water was this like fog, and we're like, what is that? It turns out it was a bunch of fish meat.
right, yeah, yeah.
That was
Yep.
crazy.
It's
Yeah. Go ahead. Go
there
ahead. Sorry.
though the game itself is pretty cool. Like I find it relaxing to go in and like build stuff, and it's less relaxing when the little kids are playing because they like to add to things I'm building, and I'm all persnickety about it, right? Like I'm like, I just made this perfect. Why are you putting blocks of wool on top of everything? Like, what is this?
Yeah, yeah, yeah,
But
yeah. Me and
but
my
yeah,
daughter play on the same keyboard. She's learning how to spell still, so she needs some help sometimes. But
right
yeah.
on. PS4 controller hooked up to it, so I can
Mm.
sit in the same room because I like to have a controller for it. It's a little bit easier than the touchscreen. But yeah, like there's crossplay from every possible version of mine, like the computer one,
Mm.
everything to it, and like the tablet versions are like $5. Like it's super
Really?
cheap to buy the tablet version. Yeah,
I gotta look into this because they got tablets. So, but
yeah.
they were on my version of Minecraft. I never played it, but I had it from like a while back. So,
It's all my kids play on it is tablets, and
yeah,
they have older iPads, and they're just fine. No problems running it.
nice, sweet. Well, since I got you on, Ben, you want to talk about some observable stuff? It's
Yeah, yeah.
something I've been giving a lot of thought to recently, and yeah, I just recently came up with a open source project. I don't want to talk about that too much because I know you haven't looked at it, but trying to build some state management framework that's kind of domain agnostic using RxJS, but maybe like abstracting it away so people don't have to do too much RxJS stuff with it, like kind of maybe like a spiritual successor to NGRX a little bit in that regard.
Yeah.
But I don't know. I'm interested in playing around with it, but I want to ask you though. Let's start with this question here: the pros and cons of observables. I'd be really interested to hear your take on like what are the big pros to observables or RxJS versus the cons
Sure.
of using it.
I mean, so just to talk about observables, not just RxJS, like the pro
Sure.
of observable is that it is, um, it's a primitive. It's a very low level primitive that you can use to build a very wide variety of things, and it can be used to represent, like concretely represent events or values over time as a collection of things, right? Or a set of things, if you will.
Yeah.
So that's the big advantage there. And then it's got cancellation, and it can pretty much represent anything, like any number of values over any amount of time, whether it's instant or infinite, infinite number of values, zero values. Like you can pretty much model anything you want in observables, realistically, like literally anything. You could build promise from observable. You could build async iterable from observables. Like you can't really go the other way around,
Right.
and for a variety of reasons. But that's the pros of observable. RxJS and operators, it kind of gives you like this. How do I put it? It's kind of like you get your own domain specific language on top of observables, right? Like, so you have all these, there's 60, 70 different named things that you can do with these sets of events that I already said you could kind of model anything after. And they're really well tested. They're very battle tested. It gets used a lot all over the place. Like it's definitely used at scale, like big scale. Like just just to make a point of it, like Angular core, I think it's downloaded like 2 million times a week. RxJS, I think last I looked, was getting downloaded like 27 million times a week.
I know. It's crazy
Right,
to see how much more that one is.
Right.
RxJS,
and it seems like the majority of the users at this point are actually using it in React and Vue and Node and a lot of other places. And that's
interesting.
It's while a lot of the documentation and like articles and stuff, I think, come from the Angular community, like the vast majority of RxJS users are not Angular users anymore, which is
kind of
a strange twist.
Yeah. Do you feel like there's maybe a delay on RxJS's popularity in some of these other communities? Is that your sense?
Well, I mean, historically, there's been a delay, right? Like RxJS was around for 6 years before I even heard of it, right?
Yeah.
So there's it's the being adopted. It was the same thing for TypeScript. Being adopted by Angular made it very popular, but then people were like, "Oh, wait, this thing is really useful outside of Angular." Like, and that's what happened with TypeScript. And I mean, that happened very rapidly. Well, not very rapidly. It happened, and like all of a sudden, it was like, oh, okay, then Ember kind of adopted it, and then like someone's like, well, I think I want this in React. And everyone's like, oh, that's stupid. Why would you? Oh my God, this is amazing. And they all started doing it too, right?
Yeah.
So
it did seem like there's a lot of like friction there, right? For TypeScript, I think for RxJS too.
RxJS has more friction. It's got much more friction. And the reason for that is, the downsides of RxJS, which are intimately related to its upsides, right? Like, you have a DSL you have to learn, right? Like you've got a new primitive that you need to wrap your head around. And it's something that when someone gets real excited about operators and stuff, like it becomes like the needing to know these things becomes pervasive in your app. Like people start to use it for everything because they're like, it's like they have an observable of something and they're like, oh, if I only made this other thing into an observable, then I could join them together in this cool way.
Yeah. And well, like you said, you could use them for anything. So it's very tempting. It's like a siren song once you get into it. So
right. And I think that people would do well to like not overdo it. Like people do it like they're like, oh, I've got this cool abstraction. And it's like one of those things where you could write a function around everything, right? Like you could be like, oh, every time I want to set a variable, I'm going to write a function that does that. And every time I want to get the variable, I'm going to write a function that does that.
I feel so attacked right now, Ben.
And right. Well, but you could do that and you could be like, oh, now check this out. Look at my functional programming wizardry. And I do all this stuff. But now you have unmaintainable gobbledygook and the next person that comes along is be like, I don't know what to do with this. And even if it works, like you've added a lot of overhead from additional abstractions you didn't need. And the next person that comes along wants to murder you because you've literally wrapped everything in a function.
Yeah.
Right. So like it's the exact same thing. Like you don't want to wrap everything in observables. And, I think that one unfortunate side effect is that people will come across these apps that are frankly just people overdid it. And they blame RxJS because of the poorly written app, when the fact is, like, it's not RxJS. It's not even the availability of RxJS that made someone write bad code. It is bad coding.
Yeah.
Like it's the lack of like a senior level understanding of like, do I really need to put an abstraction around this, or can I just inline it? Do I really need to like separate all the concerns? Like, and how deep does all the concerns really go? Right? Like it's
I hear that very strongly. I've been thinking a good bit about signal and noise ratio a lot. I think like there's a lot that functions can do. I think that in general they get underused. And personally, I think observables do too. But like they get functions I think get underused in a lot of cases where there's just like too much signal running around, where you have too much context, maybe in a scope. But like you said, if you overdo it, you go the other way on that signal to noise ratio. Right. It still is the same problem. It's just like you're just doing it in the opposite direction. So
there is one more pro for RxJS that are specifically observables that I didn't mention, which is observable. The type has a lot of guarantees around memory management and control, right? Like, so provided that as long as you set your observable up properly, when you're writing, your new observable constructor, you're guaranteed that it's going to attempt to tear down resources or to finalize. It's got like a finalization step. So if it errors or completes or someone unsubscribes, it's guaranteed to call that stuff no matter what. So since all of that ends up being the same shape, then it's much easier to write code that isn't going to leak memory. And like but sometimes, I mean, of course, I'm in a hot path of seeing what people do wrong with RxJS. And sometimes you will see people make mistakes where they do leak memory, but it's usually not because of observable. It's usually because they closed over something, and the truth of the matter is asynchronous code is hard. And if they thought to themselves for a second, like, oh, I could write something with functions and promises, it's going to be way better than this, like, they are going to be sorely mistaken and realize pretty quickly, if it's an advanced enough use case, they're going to realize pretty quickly that well, actually, no, most people don't realize that they're shooting themselves in the foot. Instead, they just shoot themselves in the foot and remain blissfully unaware that they've created other problems or memory leaks or things like that.
So like as opposed to memory leaks with like promises not resolving and things of that nature, when you're trying to set up one of these more complex async flows without observables.
Well, the memory leaks with promises too, they're no more nefarious than that now with async await, right? Like, if you have an async function, everything that's in scope of that function remains in memory for the duration of whatever that async process is. So if you have an async function that's doing like a for loop inside there, that's just continuously, hitting whatever, and you have some huge object above that allocated in that async function, even if it's not used below that for loop, it's going to stay in memory until you're done. Like, it's
interesting.
And people don't realize that. Like, there's like literally anything that happens. So anything that happens to be in scope. So like, for example, another interesting side of this is like, what happens when you have an async function on a class, right? Or a class instance, right? So you have a method on a class that is an async function. And if it's a really long running async function that either doesn't resolve or it starts some process that goes for and over, it's closing over the actual instance, right? And therefore everything that's attached to that instance. So there's a lot of, and people don't realize that. They just think, oh, it's a function that's doing things. And like, it's not quite. So observable doesn't have any of those hindrances, but it also doesn't have like language level niceties like await and whatever that kind of make things look imperative even though they're not.
Right.
So
right. Do you think it will ever be standard at this point?
No,
observables? No, that's
that's
unfortunate.
realistically, like it's still on the table, and I've talked with TC39 members about it, and
Yeah.
there are TC39 members that are very interested in it, but like, I have absolutely no faith that I can ever get a feature that I want through the TC39. So,
That's unfortunate. It
um,
seems like such, like you said, it's a low-level primitive. It seems like
right,
such a gap that we have. We
it's
have promises and iterators and async iterators, but we don't have the observable.
right. You don't have the tool. You don't have like the one tool that you would need to produce a lot of other things. But
Yeah.
I don't know. Maybe I'm just being cynical, I guess. Maybe it'll land, but I have sincere doubts. The committee, like its best hope, honestly, was when the Chrome team was interested in it, and it was really unfortunate that all that happened before Edge became Chromium based, because the Chrome team was interested. Google had lined up a contractor to do the work of adding it. And there was a very popular proposal that was like, hey, what if we added observable to the browser, like not to Node, but to the browser, and use that for event target? And the trick there is once it's in the browser, it's also in Node, because you're going to want to, like, the Node's going to be like, well, we also have event target and we want this too. And then, that's the circumventing of the TC39 that the TC39 members don't like, but it's possible. At this point, I'm just going to say it's unlikely, because the only way anything gets through those committees is if a paid member of the committee, or a paying company that's a member of the committee, literally pays someone to do this, like a nearly like full-time, part-time job, to get the standard pushed through.
Yeah.
And then they're up against a lot of opposition, because I would say that those committees, specifically the TC39, have notorious not invented here. This is the popular choice, I want something different sort of mentality when it comes to features. And I don't know. I've got speculation as to why that is, but it's purely speculation. And I just think that the odds of it getting standardized are low, not gone, because as I said,
I have hope.
There are people in the committee, people that I even like disagree with on a great number of things, that think that observable should be in a language.
Yeah.
So it's I would give it a higher chance of landing in Node or a browser
first,
than landing,
and then circumventing into the standard, you think?
right.
Okay. Well, it seems like a path forward. We'll see.
Right. We'll see.
Yeah. One thing I wanted to latch on to from what you were saying, just like how observables could be used for anything. So I was looking at just higher order functions a little bit recently, and one thing that's really interesting about them, I feel like you can really parameterize behavior, or not behavior, but functionality, by passing in a function. It seems to me like by having a function that takes in an observable as a parameter, you can really like parameterize like behavior entirely, just by, like we said, the sort of like a timeline of events that come in as a parameter. That timeline is completely open. It could be anything. Like it could be if it's observable of user clicks, like that handles all potential futures for however that user might happen to click,
Right.
So that in particular, I'm very long on, and I think that's like that particular notion, I think, is core to what an operator is. Yeah, because an operator is like a function that will take an observable and return a new one.
Correct.
So
that's right.
Yeah. I don't know. The whole thing blows my mind to just how elegant it is, but how simple it is at the same time. Like this is what makes me so jazzed, I guess, on RxJS in general.
Yeah. I mean, it's a special shaped function that's custom tailored for eventing and like finalization and that sort of thing. So, it's one of those things where if you can imagine an event for anything, And you can imagine the setup of whatever produces those events and the tear down of whatever that produces those events. Like you can create an observable from it. And, therefore, you could literally write, I don't know, an operating system that was an observable that you subscribe to boot the operating, like that's ridiculous, obviously. But
you giving me ideas here, Ben.
Right. Now, that said, like what you're doing when you do that then is you're using like a domain specific language inside of another language to model asynchrony, which is a deceptively difficult thing to model, right? Like it's people think like, oh, I'm the like they think of themselves, I'm the greatest programmer in the world because I can write imperative code that goes down this way, right? And they read it. And one of the siren song of async await is that, oh, now I've made asynchronous code look like synchronous code, right?
Yeah.
Because I'm reading it top to bottom. And here's the thing, like synchronous code is very easy. It reads like a book. You read top to bottom. You can dive into things, kind of choose your own adventure style or whatever, because there's like if statements and whatever. But at the end of the day, you know very directly like what order things are going to be executed in.
Yeah.
Now, asynchronous code, no matter how you model it, is never going to read like that ever. Like it's absolutely it's you're reading a book, and then you get to a certain point and you're interrupted by another passage from the book that could be from a random point somewhere else. Like, and then you do that. And then there's a long pause and you are made to forget about what you were just doing. And then you come back and you continue reading somewhere else. And like, there's no, depending on how all of this is channeled, it's not just if this, then this, if this, then this. It is, given, like, instead of just if then, given some broad collective state of the universe, then this thing's going to be executed, right? Like I've scheduled it. If the server happens to respond, I'm going to get something back. If it never responds, then I guess I'm going to time out. Maybe if I don't time out, then then the app is just hung up in limbo. And it's like there's asynchronously by asynchronous code. Synchronous code is like a contained like thing. It's almost a pure function of sorts, right? Like it's not a pure function, but I'm saying like it's a finite contained thing that's easy to manage.
Yeah.
Where like, asynchronous code like literally reaches out into the universe and says, hey, what else out there am I interacting with? And waits for a response from this thing and then just pops it on some event loop and then you're executing it, right? Like it's
right. Yeah, so like synchronous code operates almost as like it's flattened, I think, on some dimension that asynchronous code has full access to. Is that kind of what you're getting at? Or?
Right. Well, I guess I'm getting at that synchronous code, you can read the instructions about what's going to happen directly in front of your eyes. And asynchronous code inherently is taking instruction from something that's not in your code, right? Like it's making a call out to some other system. It's making a call out to wait for someone to click a button, or wait for someone to move their mouse, or wait for a WebSocket to give you something, or wait for, whatever, like the network to go down, or whatever that event is that you're waiting for. You've basically you've taken your logic as you're processing it, and you've given up control of it to some external force, and you're waiting for it to come back. And then you can start looking through your logic again. And that is why people have a hard time with asynchrony. It's 100% because synchronous code is totally contained in front of your eyes and you can look and see where things are going. And asynchronous code is it's a victim of nature, right? Like there's gonna be network calls or something that
like a distributed system, but sometimes the system you're distributing to is like the user itself. Yeah.
Right.
So yeah, that's interesting. But yeah, so one thing I've observed, I guess you could say, is like back-end code, and maybe I've just done really simple stuff in terms of the back end, in terms of just like REST APIs and maybe some WebSockets here or there. But at least for like REST APIs, it feels like async await actually works really, really well. Because the events coming in, like there's the one event coming in, and then like you said, you kind of have to make some, if you make network calls, you have to await those responses because you're going out to another system. But in general, that can do one of two things. I think that can like succeed or can fail. And that doesn't seem too hard to do. And then it feels like async await with maybe try catching on that. I think actually works really well.
So you're right. It works very well, especially in this simple case.
Yeah.
Where async await falls on its face is when you've got, let's say you get a REST call. So this is a real thing that I encountered at work. So you have if you have a REST call or an RPC call or whatever comes in, and it hits this HTTP endpoint, and inside of this HTTP endpoint, it was doing a number of asynchronous things. So it would say like, okay, update this row in the database, then delete this row in the database, then make this call out of the network and get some data, then mix these two things together, and then update this row in the database, then update this row in the database, and so on and so forth. Now, on the surface, you look at it and you're like, oh, this is great. But what ends up happening now is two different users can call and act upon the same data by hitting the same endpoint. And now what happens is you're interleaving those async, like between each await, there's different async contexts. And now you've got interleaved async contexts where it's saying, okay, add this to the database. No, delete this from the database. No, do this. No, make this network call. Now you make this network call. Then you delete this. Then you update this. And they're trampling each other. Yeah. Right. You can create race conditions that are not controlled by your code. Right. Like that's, and the solution for that in this case, actually, the quickest fix in this one particular case was to literally funnel all requests through an observable and wrap that entire async function in a concat map. Yeah. Right. So it resolves one promise. So it's basically just making sure that it's only ever doing one at a time. And that was a temporary fix. There's other fixes that were done after that, but that was the most immediate fix was to. That's really cool. Because so
you're load balancing with observables at that point. Yeah. Like
basically, well, you're kind of, you're locking transactions in, right? Like, so generally speaking, you only get one at a time, but if you get two at a time, you want to make sure you only process one, right? In that particular case. And eventually the whole thing was fixed. It was, but like the thing is you look at that async the ultimate fix. I'm trying to think in that case. Actually in that case, I think I went through and narrowed it down to like a single database transaction, like a bigger stored procedure that did what was supposed to be done. And then, like the network call was something that could be done after that whole thing landed. So it was very much like do this thing, one call, and then do this other thing. And then there was no reason to worry about it because the database would manage like to make sure things weren't trampling each other. But like at the end of the day though, this isn't a problem that's unique, right? Like this could happen with if you have more than one await and it's acting, they're both acting on the same data or the same external thing on an HTTP endpoint in Node, and two people hit it simultaneously and act on it, you've now got a race condition. Yeah. Right. And it's impossible to really see when you're looking at, because you just look at the code and you think, well, this is so simple, because it makes people think they're dealing with synchronous code. So it makes them feel like, I've got control over this. I understand it because everything. But anytime you see a await in there, the truth is you lost control wherever the await was, and you have to do something to make sure you maintain control or know what your environment is like when that await comes back.
Yeah, like whenever I see async await, the mental model in my mind is like, well, okay, we're going to block on this await until that happens. But that's not really what's going on, and I like know that in the back of my head. But it's nice, at least in the sense of like focusing in on a problem to just be able to think of it that way, to read the asynchronous code as asynchronous, even though it's not. So
Right.
yeah, I get it. But yeah, I was going to ask something else here. Oh, so the inverse of the statement that like async await seems really good for backend is it seems particularly poor for front end, because the front end is like this. It's like a whirlwind or a whirlwind of events that can happen all in any kind of order, because it's like the user driving, and the user, depending on the user's motives or personality, even, like that's going to happen in completely different orders. And unless you have something like, in my opinion, unless you have something like RxJS to like manage that well and to like compose on that well, it feels like you're going to have a hard time.
Right.
So.
I mean, yeah, I generally agree with that statement. People might be surprised to find out that I frequently just use fetch and async await for the like relatively common case low level things. Where, I think a type like observable is more correct, right? Because you can be like, oh, I'm going to abort this fetch if someone like starts another one, let's say. And in some cases, like for like your look ahead typing or something like that, where things are happening relatively rapidly, that's true. But like I've found that in cases where you say you've got some component and it's just supposed to, and this doesn't, usually if I'm working on something, it's got streaming data. So but if you got some component, it needs to just go fetch so like one piece of data before you start the stream. Oftentimes I'll just use async await, and the reason I do that is, I mean, honestly, the odds that they're going to pop the component open and close the component or hit the button so fast that the backend doesn't respond before, whatever, or it responds out of order because of some weird circumstances, it's possible, but it's so low that engineering for it is probably a mistake. But at the same time, like, it's, if I see a situation where I'm like, oh yeah, this is something that could take a long time and I might need to cancel it, or this is something that is ongoing and I might need to like turn it off or cancel it, then observable is totally the right way to go. And the main reason I end up using async await is usually just the availability of promise-based APIs, right? Like it's like there's fetch, so I could just use fetch. Like RxJS we have from fetch, but like when I'm making a call to just get like one time get something, if I don't need to abort it, then there's not a big advantage to using from fetch. There's only an advantage if I actually need the cancellation. And but I do use I use fetch from fetch all the time we do a lot of HTTP2 real-time streaming data, where you've got like an HTTP2 connection that's just open and pumping things at you. And you can't use
like
server
WebSocket?
No, it's more like a server sent event. But with server sent events, you can't alter the headers to send like authorization or anything with it. So like you can do like from fetch and actually read from the body and like chunk things and like output it. So actually I'm planning on giving a talk about this in the near future. So
that's awesome. I will look forward to that. I've been messing around with in my own code. I try not to do this in places where other people have to mess with it, but like observable code, but I'll switch map to like an asynchronous function. And the asynchronous function is just there to like maybe chain some HTTP requests in order. Like I need the one and then I need the other one. Sometimes it feels like a little cumbersome to concat map in that situation from the one to the next, versus like async. The async function kind of can handle that really well, it seems like. So
right.
I don't know. Is that similar? Would you do that? That's maybe a better question. Would you ever do that, or would you just reach for the concat map for these kind of sequential calls?
Like for sequential calls where I just want to do one thing and then the next thing, the next thing.
Yeah.
I don't know. Like I think that it depends. It depends on what it's doing. The gnarly thing about doing sequential calls with an async function is that if you do have cancellation and you care about it, like sometimes you don't care. If you don't care about cancellation, then absolutely I would just use an async function because it's easier for everyone to read and whatever. If I care about cancellation, I'm probably going to do the concat map route. And the reason being is what you end up having to do is having to do a thing where you're like, okay, run this function and you've got some Boolean or bit that you've closed over. And you're like, okay, await this thing. Now check the bit to see if you've canceled. And if you've canceled, then return. Otherwise, await this next thing. And when it comes back, you're like, okay, now check the bit to see if you've canceled. Otherwise, and every
that
single
seems
time.
Terrible.
Well, no, but the truth is, if you see a big async function, and after every await, you don't see them saying if canceled, return. If you don't see something like that. Then they're wasting resources. Guaranteed. Gotcha. 100% guaranteed they're wasting resources.
Make a network request they don't need to make. All that
making
kind of stuff.
Bloating memory, etc. So but whenever it's an async await where it's just like, oh, it's just a quick call and they're hitting some really fast localized endpoint. Who cares? Like, go ahead and waste it. It'll get garbage collected. You'll be fine. Like, worry about performance when you actually have a performance problem.
Yeah. That's really
other than bundle size. You don't want to say that about bundle size, but like when it comes to actual memory usage or CPU usage, usually those things aren't the big bottleneck. They can be.
Yeah.
They can, on resource constrained devices that have really shitty network connections. Using a lot of async await and making just tons of calls and never ever making sure that you're canceling is a big mistake, because like if you're on like a 3G connection on the world's crappiest Android device, then you're eating your little single core squirrel in a wheel like CPU to go fetch things over a starved network connection that you're not even going to use, right? So that's a, if I was the Alex Russell of the world that was always ranting about how everyone's screwing over the people in these like poor places with crappy phones and crappy connections. I would firmly point at async await users that aren't properly checking to see if they've canceled as a source of problems, right?
Yeah, that makes sense. Very cool, man. Hey, I think we're about at time. Yeah. Do you have any more time? Yeah, let's call it here. Hey, I really appreciate your time on this, Ben. It's always great to hear your thoughts on these kinds of things, and just wanted to put out some gratitude for the work you do. Like RxJS 7, awesome. Y'all, how much did you decrease the size by? It was like
nearly 50%. So it's
that's
down
intense,
to.
Man.
It started off at like 94 kilobytes and ended up at 53 kilobytes or something like that. So for the kitchen sink, if you include everything, if you have a smaller app that doesn't use as much Rx, like your wins are not going to be as big.
I use them all, Ben. I use them all, so I'm getting a big benefit. But thank you for doing all that work. Like just like you were talking about, how many million downloads you get monthly, and to get that kind of improvement on it. That's you're doing
a nickel a download,
thing, man. That's how you gotta monetize this thing, dude.
I would only take it for like 2 weeks, just for 2 weeks, a nickel a download, and then I would retire after that. But
nice, man. Well,
but yeah.
In the absence
you got a
of
picture.
those nickels,
is that Jeff up behind you?
Yeah, that's Jeff.
You should get my picture and put it above his just to see what he says.
I'll do that sometime. I've been trying to get Victor up here too, but every time I try to print out the picture of him, our printer doesn't work. So
that's because Victor is an actual vampire. You didn't know that, but it's true. He can't be seen in mirrors or printed by machines. Yeah,
that's awesome. All right. Well, thanks, Ben. Appreciate you.
All right.